All right, you guys, so this is SAT prep lesson number 8. There is several questions. There's actually a whole section of standards dedicated to basic probability and statistics on the math SAT. So this is lesson number 8. If you want to fill it out as I'm kind of talking, or if you want to just try the practice problems and get a brief explanation, whatever works for you is great for me. But what I'm going to talk about first of all is I just want to refresh your memory. There's a lot of people that have not taken statistics class that are taking the SAT, and so probability and statistics really kind of freaks them out. But these are a lot of words that you probably learned in Algebra 1 and Algebra 2, so just keep that in mind. The mean means average. You probably know how to average things up together. The median is the middle value, and just remember that if there isn't a middle value, aka if you have an even number of things, then you take the two middle ones and average them together. The mode is the value that occurs the most, and so keep in mind that there could be no mode if there is 0 numbers that are repeated, or there could be more than one mode. Like maybe a certain test score happens to happen 3 times, and another test score also happens 3 times. So you could have 2 modes, so keep that in mind. Range, max minus min, and probability is the number of options of winning in the numerator, and then total number of options total goes in the bottom, the denominator. So keep that in mind also. Just a brief refresher on some of that vocabulary. I just have a couple practice problems here. So there are a couple grid-ins that we're going to start with. So remember, the SAT does ask some questions that are grid-ins, meaning they're not multiple choice. You have to actually come up with an answer yourself and bubble it. So average score for a class on a biology quiz was 80. And 20% of the class gets a 90, 30% gets a 70. What was the average score for the rest of the class? So there's kind of a lot going on in this question. So if we have 20% and 30% accounted for in the class, that means the rest of the class, quote unquote, is the rest of the 50%. And so we also know that 20% of the class scores a 90. And so I'm going to represent that with an equation here. 0.2 for 20% times 90. 30% scored a 70, so same thing. Remember, when you average stuff together, you add up all the total amount of things, divide by the number of things there are, and that in this case equals 80. They're giving us the 80, and we have to solve for this x right here. What did this score? What did the remaining 50% of the class score? What goes in the denominator here is a little bit tricky. So because I'm using percentages here, 0.2, 0.3, and 0.5, that adds up to 100%. And we do not know the total number of people in this biology class. But because everything is in terms of percents here, I'm just dividing by 1. That's the same thing as 100%. That is because I do not know the number of people that fall into either of these categories or the entire class. So it's kind of like keeping your units consistent. This is in percent, this is in percent, this is in percent, and that is also in percent. So the total percent that we're accounting for here is 100% of this biology class. Equal it to 80, go ahead and solve. You end up with 82, and it does say ignore the percent sign when gridding your answer. So 82 goes here, or you can put it first. Number 2, shoe sizes of 10 men. How much greater is the mode than the median? So again, SAT is famous for asking kind of multiple questions in one. You have to know what the mode means, and you have to know what the median means to be able to get this question right. So first thing I would do, since there are only 10 men here, these are not in order. I would go ahead and order them. So write them in ascending order. So the smallest shoe size of these 10 men is 6. The biggest shoe size is 12. When you write them in order, this is an even number of dudes. So we do not have one person in the middle, we have 2. And again, the middle is the median. You average them together if there is not a middle person. So that middle number is 9.5 shoe size. The mode, the number that occurs the most, let's see, I have 2 7s, I have 3 10s. Okay, cool, so the mode is 10. And it does ask how much greater is the mode than the median. So when you subtract those, you get 0.5. Number 3, a set of data has 10 values, none of which are the same. I hate it when the SAT does this, but they give hypotheticals and they don't give you numbers to work with. So I made up my own numbers here. Test taking strategy. 10 numbers, none of which are the same. I just quickly wrote out 1 through 10. So I have a set of numbers to look at. If the smallest value is removed, so okay, get rid of the 1, Which of the following statements must be true? The range of the first, which is the original data set, is greater than the range of the second one. That's true because my range before I got rid of the 1 was 10 minus 1, which was 9. And then after I got rid of the 1, I have 10 minus 2, which is 8. So letter A is true. The range of the first data set is bigger than the range of the second data set. The mode of the first data set is greater than the mode of the second. Well, we don't have a mode because none of which are the same, so that's not true. The medians of the two data sets are the same. Well, the median of the numbers 1 through 10 is 5.5 because there isn't a middle number. But if I get rid of the 1, now I only have 9 numbers, and that means my middle number is 6. So those are different. So C is not true. And the mean of the first data set is greater than the mean. Conceptually, hopefully you understand why D is not correct. If you get rid of the lowest person, your average goes up. So letter D is false. Number 4, in this semester, Jerry scored an average of 93 on 5 history exams. So we have 5 tests divided by 5. The average is 93. He got the same score on his first 2 exams. I'm going to call those X because they don't tell us what the score is. So on the first 2 exams, that means you have 2 X's there. And then he got an 94, 85, 90. So those are my other 3 test scores. Go ahead and just set up this equation and solve. Start by multiplying both sides by 5. Combine your X's, which gives you 2X, and solve, and you get 98. So that is algebraically the way to come up with the answer here. You guys, it might even be faster if you have a calculator on this problem to just guess and check and go 95 plus 95 plus 94 plus 85 plus 90 over 5, see if it equals 93. And you could guess and check without setting up an equation here. Depending on how your math skills are and how comfortable you are with averages and stuff and writing your own equations, that might be a better method for you. Don't forget, you guys can guess and check if you're running out of time. Number 5, we've got a class of 25 students, so we know the number of students here in this case. That's my denominator. Took a 3-question quiz. Here is all the quiz scores, so if the people that got all 3 questions wrong, there were 2 of them. Poor people, okay. Let's see, the table shows possible scores and number of students who received these scores. What is the average of the scores on this class? So I did have 2 students that got a 0. So instead of averaging and adding up 25 numbers, there's a faster way to do the same exact thing. Instead of going 0 plus 0 plus 10 plus 10 plus 10 plus 10, because that happened 4 times, plus 20 plus 20 plus 20, and writing that out 13 times, there's a faster way to do that. So just take number of students times that quiz score. There were 2 zeros, there were 4 10s, there were 13 20s, and there were 6 30s. Divide by 25 students total in the class, and that gives you 19.2. Couple questions left. Number 7, for a set of 11 different rational numbers. Remember, rational just means can be written as a fraction. Which of the following cannot affect the value of the median? So 11 different rational numbers. If you want to write out the numbers 1 through 11, you could do that. I for some reason didn't feel the need to do that on this one. If you double each number, then that means the middle number also get doubled. Okay, so that's letter A. Increasing each number by 10, that means the middle number also gets increased. Increasing the smallest number only. Oh, if you increase the smallest number, there is a chance that it could become the middle number if you increase it the right amount. So think of lining up the numbers 1 through 11 and taking the 1 and adding something to it. You could move that 1 up to become the middle number. If you increase the largest number only, that just makes the largest number still be the largest. So the middle number doesn't change in that case. So that's our answer for number 7. 2 left. We've got a bar graph now. Very similar. This question is really similar to this one. They're just giving us the data not in a table, but in a bar graph. So we have absences. What this means is we have 5 students that missed 0 days. We have 4 students that missed 1 day, etc. And so coming up with the average for that is very similar to the question number 6 that we did. There were 5 students that missed 0 days. So instead of saying like 0 plus 0 plus 0 plus 0 plus 0, we can just multiply them. There are 4 students that missed 1 day, so that means if I were adding them up, I would have 4 ones all being added together. You could do this the slow way or you could do this the fast way. There are 20 students total. They weren't giving us that information in this question. I had to figure that out based on adding up these numbers. And that's how we get 34 out of 20, which is an average of 1.7 days. Very last question, which I thought was kind of one of the harder ones. We have a 2-digit number from 10 to 99. What's the probability that the number is divisible by 5? So on the top is the total numbers in here that are divisible by 5. The bottom is the total numbers in here, period. So first of all, I got a little confused, but I had to start making a list of numbers that were divisible by 5. In this case, 10 and 15, 20 and 25, it looks like for every single increment, there are 2 numbers that are divisible by 5. So 10, 20, 30, 40, 50, 60, 70, 80, 90, that's 9 increments, and there are 2 numbers in each of those increments that are divisible by 5. So that's 18 numbers, that's my numerator. And then I've got 10 numbers in the 10s, 10 number in the 20s, 10 numbers in the 30s, etc. All the total numbers between 10 and 99, including both of them, which means you can't do a subtraction here. You are including 10 and 99, is 90 numbers. That goes in the denominator. When you divide that, you get 0.2.